In the diagram, four circles of radius 4 units intersect at the origin. What is the number of square units in the area of the shaded region? Express your answer in terms of pi. Um, to work out this question, we have to note certain things. That is, the first thing is all the four circles are equal in radius. So that means they're equal in area. So, and what else is it? Yeah, and the fact that this one, you see this, they pass through the origin. What really that means is these lines, they are the diameter of the circle. This is the diameter, and this would be the radius of the circle. I mean, this would be the diameter as well, but like this would be the diameter, and this would be the radius of the circle from here to here. This is the radius, 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 again the radius, and again the radius, 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 and radius. So what we can do is, we can say that the area of the shaded part, or we can say, if we are to draw once again, sorry, not that line, we have to join these points where the circles touch, and we see that this is a square. The reason is this is the diameter, radius and radius, radius and radius, diameter, and they are all equal, so this is a square. Now if I am to find the area of the shaded region, I am going to start with naming them. So I can say that the entire region, all this is A. So if I call them all A, being the area of the shaded region, and if I call this little part, the white part here, B, and this part here, C. So what I have done is, if I were to draw a square again, it's the square. If I name it A, B, C, D, and I've drawn here A, B, C, D again. So what happens is, if you have these lines, and then you see this is what happens. So my drawing is not perfect. It's actually far away from perfect. But I'm trying to, I think it explains the problem. So what we see is, of course, this is the area that we have to find out. This is the A part. And may I name this as B and this also as B. So they are equal. This equals this. So this square, this is all the radius. So this is 4, this 4, 4, 4, 4, and 4. So I have to only find the area of A. So area of this square, if I put it in red, so area of this square, if I say one of the small squares, so area of the small square equals 4 times 4, that is 16 square units. Now the small square, I can also write it as A plus twice of B equals 16. So the area of A plus the area of B and plus the area of the other B is 16. So A plus twice B is 16. So now we have to do the second step. The second step is this, that if this is the square, you see this is the quarter of a circle. So this one, this is quarter of the circle, and also this is the other quarter of a circle. So this is like overlapping two quarters of two circles which are same in area, so being the same in radius. So what we can also say that A plus B, because this is the area of the quarter circle, so if I may say that this area is A plus B, area of a quarter circle, so A plus B equals the quarter of a circle. Area is pi r square out of 4, in this case r is 4, so I can write pi times 4 times 4 out of 4. That gives me 4 pi, and that is A plus B. So I got A plus B is 4 pi. Or I can say that B, because here B is the unknown, we are not interested in B, we want to find A. So we can say that B equals 4 pi minus A. So if I call this as equation 1, and if I call this 2, so using 1 and 2 or substituting the value of B from 2 and putting it in 1, I will get A plus 2B, so twice of 4 pi minus A equals 16. Or I can write this as A plus 8 pi minus 2A equals 16, and minus A plus 8 pi equals 16, and that means, or you can say, that implies that A equals, changing sides, 8 pi minus 16. Now this A is only the area of one of these petal shaped, or one of these shaded structures. Now there are 4 shaded structures, so I have to find 4A, and that equals 4 times 8 pi minus 16, and that gives me 32 pi minus 64, and that's in square units, and that's the answer, 32 pi minus 64.